This is the 9th video of the tutorial about history analysis in RayJack ONE. This video is about hotspot analysis, one of RayJack ONE's most useful features for stray light analysis and other applications. In the previous videos we have already seen this toy model of a Kepler telescope. Behind the telescope there is a screen with an irradiance detector. The history detector is set up to collect the full range of available history data. Let us run the ray tracing and afterwards inspect the irradiance detector results. The irradiance detector shows the nominal light together with the signatures of several ghost images. Let us assume that we were interested in this sharp feature at the bottom part of the irradiance distribution, and that we wanted to study the rays that hit the screen in this region. This is where hotspot analysis comes into play. In order to launch the hotspot analysis, we use the following command. History.hotspot. The first input argument is the irradiance detector. The second argument is the physical object to which it belongs. When we run this line of code, a new distribution viewer window opens up. First, we need to adapt the scale to a logarithmic color scale and adapt the minimal value such that the ghost becomes visible. Next, we click on the menu button with the flame symbol, and then we can use the left mouse button to draw a rectangular, circular, or elliptical region into the irradiance distribution. When we have specified a region, we can right-click on it and then, for example, show the trajectories of those rays that hit the screen in the specified region. We can also right-click to open the paths of the corresponding rays in a grid view. The rays in the specified region belong to several different paths, but the ones with the most flux are the paths with the ID number 24 and the ID number 563. I right-click on path ID 24, show the corresponding rays in the system view, and we can see that indeed this path has the rays that show the feature that we were interested in. If needed, we can also use the Boolean union and trimming operators to draw a more accurate region around the feature that we want to study. We could, for example, start with an ellipse, like this, and then trim away a circular region. And two rectangles. And now the region that we have drawn is a little bit better adapted to the feature that we want to study. Finally, it is also possible to automatically generate RayJack ONE code, which does the same things that we have done so far with mouse clicks. To this end, we right-click in the specified region and click on Get Script and open in Script Editor. In this automatically generated script, the first command translates the geometry of the region that we have drawn into RayJack ONE commands. The other commands define a ray filter from that region, get the ray copies from the history detector with that so specified ray filter, show the trajectories in the system viewer, and get the paths and show the paths in the grid view. We can use this automatically generated code either to further post-process the rays and paths with our custom post-processing code, or to influence the way how the ray trajectories are shown in the system viewer, for example, by specifying a different ray color.